Good evening students, whether my slide is visible, slide and voice are clear?
Yes, sir. Yes, sir.
Okay. Okay. Good evening to all. Now we are going to see lecture number 26, AC series motor. Okay. And this series motor, because you know the basic concept of series and parallel in electric circuits is studied. In series, the current is same, voltage is different, but in parallel voltage will be same, current will be different. So like that, this series and parallel concept which is applicable to AC motor also, that machine is known as AC series motor, and this motor is majorly used in domestic applications, that is in a mixie. Okay, most probably in mixies they are using this AC series motor. Okay, introduction. This AC series motor is also known as modified DC series motor. Why we are saying this is modified DC series means the construction which is available in DC series motor, which is just similar to this AC series motor. What is the construction there? It will be same field winding and armature winding which is available. You see this diagram. Okay, I'm going to give you a single phase supply, and this is my stator. This stator will be laminated stator, and inside there will be a rotor will be there, and this rotor is having a field coils. Okay, this is the field coils which we are seeing, and this series motor will be rotate one direction only. Okay, whether it should be in forward direction only, it should be rotate. For every off cycle it should be rotate. You see this here. Okay, there are two poles are there. When you give the supply, this red line call it as a winding. When you give the supply, the current flows in this winding, then the flux will be passed across this laminated stator, and based upon this flux the rotor will starts rotating for every off cycle. Okay, for every off cycle it will be rotating, and this series motor can run both DC supply and AC supply. And normally in DC series motor it will be operated the polarity of the supply, that is in terms of DC. Now in DC the torque is normally proportional to flux into current, armature current. T is directly proportional to flux and armature current. Like that, in DC motor, if the line terminals are reversed, then both field and armature winding as well as reversed. So the torque value remains unchanged. Therefore, the motor will continues to rotate only in the same direction. Okay, only in the same direction only it will be rotate. And when normal DC series motor is connected to AC supply, okay, you will know the basic concept of DC motor. There are two parts are available in DC motor. One is field winding, another one is armature winding. Okay, field and armature winding. And here we are, instead of DC supply, we are giving AC supply to the machine. Once you give the AC supply, both armature and field current reverse simultaneously. Therefore, an unidirectional torque is produced in this motor. Okay, therefore unidirectional torque is produced in this motor. What will happen when we give AC supply to DC motor? Okay, if we give AC supply to DC motor, an unidirectional torque is produced. Unidirectional means the motor will run only in one direction. Okay, only forward direction, not in reverse direction at a same time. And due to presence of AC current, an eddy current value which is induced in yoke and field cores which have excessive heating will be produced. So based upon the heating, the efficiency of this motor is low. Okay, because of this efficiency, there will be increase in the losses. What type of losses will be increased? That is core losses, which is available in winding. Okay, so once the losses will be increased, then the reactance value, X value present in the field winding and armature winding will be increased based on the supply. Okay, so due to this increase in the reactance value, the power factor cos phi value will be very low. Okay, cos phi value will be very low. Because of the power factor is very low, there will be spark has been taken place at the brushes. Where the brushes will be connected means which is connected in the armature part. Okay, in armature there are two parts are connected. One is commutator and brushes. This commutator will, it is a rectifier which converts AC to DC. Okay, so there is a spark will be produced. Okay, if we give AC supply to DC motor, this is one 5-mark question. If I ask this question in your internal, what will happen when you give AC supply to DC series motor means, first you please write these 5 points or 6 points, you will get 5 marks. Any doubts? Any doubts, students? Next, and if you give DC supply to the motor, in constructional part you have to make some modification in the design. Okay, that construction is mainly depends upon the some parameters which is available in the winding arrangement. That winding we have to call it as, it will be called field winding and armature winding. Okay, and if you take a DC motor, normally DC motor we have to give only DC supply. Instead of DC, now you are giving AC supply. If you give AC supply, there will be some slight changes will be taken place in the construction of the machine inside. Okay, the construction which is normally taken place in the winding arrangements. Okay, these points are already explained. Okay, that winding arrangement is called as compensating winding arrangement. Okay, compensating winding arrangement. And because we are giving AC, right, the speed value will be slightly decreased. To increase the speed and reduce the torque value for a given current, we have to change some windings inside the machine. That windings are basically called it as compensating winding. Okay, that winding are called it as compensating winding. So compensating winding is a method which is used to reduction in number of turns on the field winding, which also reduce a flux for the given current. Because of the reduction in the flux, there will increase the speed and reduce the torque available for a given current. Given current means it is 7.5 ampere as per the specification given by the manufacturer. So this compensating winding will be classified into two types. One is conductively compensated series motor. Second one, inductively compensated series motor. Okay, compensating winding is classified into two types. One is conductively compensated series motor. Second one, inductively compensated series motor. This is the conductively compensated series motor. And here because if you give AC, there will be disturbances will be there inside the machine. Finally you will get the spark. Okay, and because of power factor is very low. Okay, to prevent this sparking and power factor for the machine, we need a compensating winding. That is my first point. Okay, to prevent the machine from spark and power factor value, low power factor value, we need a compensating winding. This compensating winding arrangement called it as conductively compensated type of motor. Okay, conductively compensated type of motor. Okay, now come to our diagram. This is my circuit diagram. Here this L1 L2 are nothing but points. Okay, it is a line terminals, positive and negative. Okay, positive and negative you can put, and single phase AC supply 230 volt 50 hertz 7.5 ampere. Now this is my DC motor. Okay, this is my DC motor. This DC motor having two parts. One is field, another one is armature. Okay, armature is the rotating part. Now I am going to add a field compensating winding. this compensating winding I have to connect in series with main field winding and armature, with main field winding and armature. Students, please look into this diagram. Okay, here ma'am.
You can send, sir.
Okay, and you see this diagram, and we are taking a DC motor. DC motor is having two parts, one is field winding, another one is armature. Okay, armature is a rotating. Now field winding, here it will be connected in series with the armature. That's what we have to say, it is a DC series motor. Now here I am going to add a compensating winding. It should be connected in series with field winding as well as with armature. Okay, it should be connected in between armature and field winding. Okay, the axis, okay, the angle of this both field and armature, it should be 90 degree. Okay, the axis of compensating winding with field winding axis should be 90 degree. Okay, you see this is my 90 degree. Okay, this is my 90 degree. Okay, and the field flux produced in the axis only in C and D, because in armature there are 4 terminals which we have connected. This red color box you are seeing, this is a brushes. Okay, this is a brushes, and the field flux produced along the axis only in C and D. Okay, it is produced in C and D. The armature flux will be produced along the axis A and B. Okay, the field flux will be produced with the axis C and D. The armature flux is produced in the axis A, B. Okay, the compensating winding must produce a flux along AB direction. Okay, you see, this is AB direction. Okay, because compensating winding will be connected in series, right, within the AB. So the flux produced in compensating winding should be reflected in AB direction. Okay, AB direction. This compensating winding will be placed in stator slots and its axis should be 90 degree. Okay, should be 90 degree, and the number of turns per pole in compensating winding should be equal to number of turns per pole in main field winding. You see, in main field 1, 2, 3. Okay, 3 number of turns are there. In compensating also 3 number of turns are there. Okay, both should be similar. Okay, this compensating winding is a method which carries a current which equal the current flowing in the armature. Okay, but in opposite direction. That is nothing but conductively compensated series motor. Okay, that is nothing but conductively compensated series motor. Why we are going for this conductively compensated? To prevent the machine from excessive sparking and low power factor. For this construction purpose, we are going for this conductively compensated series motor. The second one, inductively compensated series motor. Inductively compensated means to prevent the motor from short circuit. Okay, from short circuit or high current, we need this inductively compensated. And here I am going to give same single phase AC supply. Here same DC series motor, field winding and armature. It is having 4 parts A, B, C, D. Okay. Now I am connecting a compensating winding. This compensating winding will be short circuited with armature. This compensating winding, okay, this is a winding, green color called as compensating winding, which should be I have take one wire and it should be short circuit. Okay, it should be short circuit. This short circuit term we'll call it as short circuit compensating winding. This winding which we are going to connect in series with the armature terminals, in series with armature terminals. The current flowing in this compensating winding which almost directly proportional to an armature current, and how much angle here, it is 180 degree. Okay, but in conductively commutated it is 90 degree, but here it is 180 degree. Okay, here it is 180 degree. Okay, and the third one, it is an interpole. Okay, the combination of these both two, one is conductively and inductively compensated. Here I am giving same single phase supply, there will be a motor, field winding and armature. The three terminals are there, A, B, C, D, and I am taking a compensating winding which is connected in series with the main field and armature. And across A there will be a inductive part. Okay, that inductor, combination of resistor and inductor should be connected in parallel, that is called a inductive shunt resistor. Okay, non-inductive shunt resistor. Okay, the combination of resistor and inductor which should be connected in parallel. Okay, that is known as non-inductive shunt. Shunt meaning is parallel. Okay, shunt meaning is parallel, and this non-inductive shunt resistor which will be placed in between the L2, then armature, in between the L2 and armature. Okay, and this type of structure for to change the poles. Okay, suppose if your speed and some of the parameters, okay, which will be changed sometime based upon the supply. Okay, to overcome, okay, or to manage the speed and EMF, flux, everything based upon our supply, we need this arrangement. Okay, we need this arrangement. This arrangement is known as interpoles arrangement. This arrangement is known as interpole arrangement. Then characteristics. This is the characteristics of AC series motor. My x-axis will be a torque, y-axis will be speed. Okay, x-axis torque, y-axis speed. The torque, okay, because the characteristics of AC series motor is just similar to DC series motor. What is the torque equation of DC series motor? Torque is directly proportional to Z phi NP by 60A. Okay, torque is proportional to square of armature current, and speed is inversely proportional to armature current. Okay, torque is proportional to square of armature current and speed is inversely proportional to armature current. Okay, so this DC series compared to DC series, we are getting somewhat a good torque and speed. Okay, we will get a curve, very curve shape. It should be non-linear curve. Okay, it will be hyperbolic curve, we are getting it. But in series motor, it during starting time at some loads, the starting speed of the motor is very high. Okay, due to high starting torque. Now when we operate this AC supply by in DC series motor, we can limit the starting speed based upon our starting torque. Where we are using this AC series motor means, which will be normally which is used for heavy loads as well as in terms of our domestic applications, most probably they are using in mixes. Okay, mixes they are using it. And the applications nowadays, in terms of if you go buy a mixer, there will be a different, there will be plenty number of specifications are there. Okay, 20,000 also the mixer is available in the market. The reason is that it will be operated by solid state devices. Solid state devices means it will be called a power electronic semiconductor devices by using the BJT, MOSFET, IGBT or GTO based upon the transistors. Okay, and the main application for this DC series motor or AC series motor, which is normally used for portable drills, okay, in the buildings, and hair dryers, table fans, kitchen appliances means mixes. They are using for mixes. Any doubts? Thank you. Any doubts?